Hello everyone, I'm Charith. So this is our SER502 final product submission. So we built CRAB, a custom programming language from scratch in Python. CRAB stands for the initials of our four team members, that is Charith, myself, Rahul, Akshat, and Balaji. So moving on to slide two. So here's what we'll cover today. So it's starting from language design, the lexer, the grammar, the parser, the AST interpreter, all five sample programs, and a live demo at the end of the presentation. So next slide. Uh, sorry. So CRAB is a small imperative language with C-style braces and no semicolons. So there are no parser generators, no external libraries. Everything is handwritten lexer, handwritten parser, and a tree walking interpreter. You run it from the command line with one argument, that is the source file. It satisfies every required constraint, that is booleans with and, or, not, and then integer and float arithmetic, relational operators, string assignments, if else, ternary operators, for and while loops, print statements, and the unary minus. So moving on to the next slide. So we have four primitive data types. That is the int, float, bool, and string. And there are a few runtime rules worth calling out. That is, let's say the integer is divided by another integer that gives floor division. So basically, 50 over 2 is 25 and not 25.0. Booleans print as lowercase 2 or false. Accessing an undefined variable or dividing by 0 are both runtime errors. Moving on to the pipeline. Yeah, so this is our compilation pipeline that has four stages. The lexer reads the raw source from and produces a flat list of tokens. Then the parser does recursive descent over those tokens and builds an AST. So the AST over here, that is the only intermediate form we have, and there is no bytecode. And then the interpreter then walks that tree to execute the program. Thank you.
Yeah, everyone. Hello, everyone. So I'm Balaji. So I'll be explaining the lexer. So the lexer is in lexer.py. It builds one master regular expression from an ordered list of name patterns. The order matters. The multi-character operators like equal to, not equal to, less than equal to, and greater than equal to are listed before their single character prefix, so they always match first. White space and the comments starting with the ash symbol are discarded. True and false become bool tokens, not identifiers. So for the line result equal to result, we'll be having like result equal to result into I. You get six tokens, two idents, and assign a star and ident for I and a semi. So every token carries a line number and a column for error reporting. We can go to the next slide now. Yeah. So here we have the grammar statements. So the grammar is written in EBNF. A program is a sequence of statements until the EOF. Each statement is an assignment: print, if, while, or for. The for loop header has three parts: an initializer with its semicolon, a condition, and update assignment, where there is no trailing semicolon before the closing parentheses. The else clause on if it's optional. Nested if or else is just nested blocks, no extra grammar rule needed. So we can move to the next slide. So we have the grammar, expressions, and precedents. So the grammar expressions precedence is structural. Each grammar rule calls the next level down. Ternary at the top, then or and not. Relational addition, multiplication, and unary minus at the bottom. This means the parser needs no disambiguation table at all. We can go to the next slide. Yeah, here we have the parser. So the parser is a clean recursive descent implementation in parser.py. One Python method per grammar rule. So the underscore p reads without consuming. The underscore advance consumes. The underscore expect asserts the token type or raises a parse error with line and column. As you can see, the method hierarchy on the right, it maps directly to the grammar. Yeah. Thank you.
Hi, I'm Akshat, and I'll start with the AST. The AST node types are all defined in AST nodes.py. Every language construct has a corresponding Python class. Program is at the root, then statement nodes, assign print, if, while, for, and expression nodes like binary op, unary op, ternary op, and the four literal types. Every node implements pretty indent, which is what the AST flag calls. The AST is the only intermediate form. The parser produces it, the interpreter consumes it, nothing else in between. Can you move to the next? Yeah. So here's a real example. Running factorial.trap with AST shows the full tree. Program at the root, two assigned nodes, then the for node with its init, condition, update, and body clearly separated. And finally, the print node. This is exactly what the interpreter works. Next slide, please. Yeah. So the interpreter is a tree walker in interpreter.py.self.env, is a plain Python dict, the variable store. Exec dispatches statements, evaluates expressions, and returns a Python value. Prothi handles booleans, non-zero numbers, and non-empty strings. Division by zero and type mismatches in arithmetic both raise runtime error. Now we'll talk about the five sample programs. So the first one is factorial.graph. It uses a for loop to compute 6 factorial, which is 720. After the loop, it also shows plain subtraction, float division, and unary minus. So the output is 720, 63, 25, and minus 7. Next one is Fibonacci.trap. It uses a while loop with a temporary variable pattern and then prints the first 10 Fibonacci numbers. The next one is Boolean.trap. It exercises all three Boolean operators like AND, OR, NOT, as well as compound conditions, if-else branching, and the inequality operator. Next one is Ternary.trap. It shows the ternary operator, including right associative chaining to build a multi-level grade classifier, and a case where the ternary directly produces a Boolean result. The last one is mix.crab, deliberately combines everything together. Floats, strings, float arithmetic to compute a circle area, a float comparison driving an if-else, a while countdown, and nested if-else for weather classification. It's the integration test for the whole language. Thank you.
Hi, myself Rahul. So we are done with the presentation part. Let's look at the demo for our project. So this is the GitHub repository of our project. So we have given a detailed explanation of the project, like what the project is, the tools used for the project, the folder structure for the project. The prerequisite here is the Python version should be 3.10 or more than that. So we have given some useful commands to run our program. So let's start with it. So first we can copy this command to clone the project in our repository, in our local. So once the project is cloned, we can go inside the project. We can open it in any your code editor. So as you can see, first let's check for the Python version which I have. Just a second. Okay, so Python version. Yeah, so we have Python version 3.10. It is compatible with the project. So to run the project, we have given few useful commands here. So we'll just copy. So first of all, we have few example codes inside the data folder. So we'll paste the command which is provided in the README. So we have shown the output on the slides as well. So the output is same 720, 63, 25, and 7. And to see the AST tree of this factorial code, so we have the command here as well. So just we have to add a flag -AST. So here you can see the tree structure. So of the factorial, the program at the root, the assignment, the for node, the init, and the print statement at the end. So this was the sample code run for the project. We can verify if this code is if the interpreter is running fine or not. So we'll remove a semicolon in this code and we'll just run. So as you can see, it gives an error, pass error, that the semicolon missing at the line number 15. So yeah, I'll just add it again. And this is the repo. The repo is organized with the source. Inside that we have compiler and runtime. The compiler consists of the lexer, the parser, ATS node, the crap file, which is the entry point, and the runtime folder, which consists of interpreter. And we have 5 other sample examples of the code inside the data folder, as I shown the factorial part. And the grammar PDF, the presentation, and the contribution folder is inside the doc folder. As far as the contribution goes, Charith handled the ATS node and the runtime error handling. I built the lexer and interpreter core. Akshat wrote the parser and the expression evaluation. Balaji wired up the entry point and the print formatting. And yeah, that's everything. And the language design, grammar, compiler, ATS, and the live demo for our program. So yeah, thank you.
Thank you.
Thank you, everyone.